Good day, I'm Dr. T. Welcome to my office. Today I'd like to talk about communicating chemical hazards. Let's start with the quickest and kind of least detailed approach. This one is specifically to the United States, by the way. This is the National Fire Protection Association's 704, or the Hazmat Diamond. It's broken up into 4 subdiamonds. The leftmost subdiamond is color-coded blue, and this stands for health. A 0 in this case is going to be just normal stuff, so safe, relatively speaking, where a 4 is going to be quite deadly. The top diamond is going to be color-coded red. This is for flammability. A 0, this is not flammable. A 4 is going to be readily flammable at 25 degrees Celsius or less. 25 degrees Celsius is a slightly warm room temperature. So yeah, this stuff burns, and it burns good. The rightmost diamond is going to be color-coded yellow. This is for chemical reactivity. 0, it's stable. It's not going to do anything too exciting. 1 and 2, this can be somewhat reactive. You can get a fairly energetic reaction going on over here. 3 and 4, it can detonate. Detonate is the technical word for explode, go kaboom. Beware of this one. The bottommost diamond is color-coded white, and in this case, this is going to be kind of the other category. Any special hazards that are not very common. Things in this category could be SA for simple asphyxiant, something like, say, nitrogen gas, where it can displace the oxygen in the room. Alternatively, you could have radioactive here, or the W with a line through it is the classic reacts violently with water. So whatever you do when fighting this fire, do not use water, which is, shall we say, very relevant if you are, a firefighter. Okay, moving on to a little bit more specifics. So moving on from something for immediate response as you're responding to a fire to looking up information on a chemical. This is going to utilize the Globally Harmonized System of Chemical Classification and Labeling, or GHS. In this case, there's going to be a few different ways that these are going to be classified. I'm going to start off with the pictograms because these are the ones you are going to notice the first. So helping me out, I have the pictograms printed, and I will put them up here as I read them off. Remember the yellow with the explosive? Well, we've got an explosive pictogram. That's going to be a cannonball exploding. So obviously, stand clear of this one. Flammable, it burns good. This is going to be a line with a flame on top of it. Oxidizing agent. This is going to be a line with a circle and a flame on the circle. Okay, just to clarify on this one. So if you recall, a fire needs fuel, oxygen, heat, as well as a chemical reaction, the good old fire trapezoid. Fuel would be the flammable stuff. Oxidizers are things that can take the place of oxygen. They are ones that steal the electrons, and, well, they're the other half of the combustion reaction. So those don't exactly burn, they make other things burn better. Things like, say, ammonium nitrate are really good oxidizers. The compressed gas cylinder is, shockingly, a compressed gas. Here it's a little bit less of a chemical hazard and much more of a physical hazard. Those things, if they are damaged, can start shooting off like missiles. Also, they can flood the room with a lot of whatever gas happens to be in there. A test tube pouring out a liquid onto a bar and another test tube pouring out a liquid onto a hand, and it's dissolving both of those. This is corrosive, and it does pretty much what the pictogram suggests. It dissolves stuff, or it causes chemical damage to things. So this will cause a chemical burn, usually quite severe. Next up, we have the exclamation point. This is a health hazard. This is going to cause some form of negative health event, chemical burn or the like. This is kind of the lower severity one. The somewhat higher severity ones are going to be the skull and crossbone. This is highly toxic. This thing can kill you with an acute exposure. So roughly speaking, this kills you quickly. The next one, the serious health hazard, the person being dissolved from the inside out, which is an apt description. These are generally a more long-term health hazard kind of situation. Carcinogens would fit into this category. And then the last is hazardous to the environment. It's a tree with a dead fish. Once again, rather self-explanatory. They did a good job of picking, symbols. Okay, so that's kind of the immediate looking at the container. Generally speaking, commercially labeled chemicals will have these on the container where relevant. Now, if you are in a lab and you are moving chemicals around, making aliquots or small subdivisions of your chemicals, or you've made your own chemical yourself, you can buy GHS stickers for them, although quite a few labs don't necessarily do that. We're kind of moving towards that way. I've also seen stickers that have little Hazmat Diamonds on them as well for you to write in the numbers to help communicate. If you have chemicals in your lab and you are not currently working with them and you are right there with them, the container needs to be labeled clearly. You need a label on that container that someone who is not familiar with chemistry can walk up to it, pull out their phone, and Google what on earth is in that container. The reason you want this is because of the next way of communicating health hazards. This is the slow but detailed approach known as the safety data sheet. This is a legal form that is required for all chemicals that are manufactured or imported. And if you buy a chemical, the manufacturer is supposed to send it with your first order of that chemical. Not to mention, the safety data sheets are all over the internet. By the way, you'll sometimes hear them referred to as material safety data sheets. That is their predecessor. In, I believe it was 2014 or 2015, the MSDS was phased out and replaced with the SDS. Functionally, they are the same thing. The main difference between the two is their formatting. I could go on to a long discussion of the multi-part structure of an SDS, but unless you're actually writing one, to be blunt, they're blindingly obvious as you read through them, so you don't have to know what, say, section 12 is. Just read through until you hit whatever you need to get. Now, within the SDS, you are almost certainly going to have those GHS pictograms on there, as well as you will have more specific information. Now, awkwardly, the globally harmonized system and the National Fire Protection Agency system both use numbering systems, but where NFPA's is 0 safe, 4 dangerous, GHS is 5 safe-ish, 1 dangerous. So they run backwards, which is rather annoying if you don't realize that fact. It can get a little bit confusing when you're reading some of the symbols because like, wow, I thought this chemical was really toxic, but it's just a 1. Yeah, no, 1 is toxic. Also, there will be things like 1A, 1B, that kind of stuff. It's a little bit more detailed, but it will tell you how it's going to try and hurt you if you're exposed to it. Gives you a lot more information. This is meant for, really anyone who needs to have safety information. It's nice and detailed. Now, the other way you get safety information is literally just Google the chemical. There will probably be some website giving you way more information about that chemical and what nasty things it might be able to do to you or weird reactions that you need to watch out for. So Google or your preferred search engine is definitely also your friend here. Of course, use proper data media literacy policies. You know what I mean. Don't believe everything you read on the internet, but weird technical stuff is usually not that fraudulent. Okay, couple other quick points. One, if you are, taking chemicals out of the original containers, putting them into other containers simply for smaller storage or because you made a new batch of the chemical, you made some solutions, whatever. Hey, it's me from the future. I apparently forgot to say what goes on a chemical label. Okay, so your chemical label does depend on what kind of chemical it is and some context. Obviously, if you're buying a pre-prepared one from a chemical manufacturer, they're going to have these nice printed labels with all kinds of information. That's not what I'm talking about. Here, I'm talking about is if you're in the lab and you are making a chemical and you're going to put it in a container and store it for any length of time. So you're going to walk away from it. So you're going to need some information on there. Ideally, you really want the name of the chemical in a format that can be Googled, especially if this is going to be any length of time. If this is something that's just going to go on a shelf and you're going to gain access to it tomorrow kind of thing, and you're going to work with it then, a little bit less strict on the labeling, but you still have to have something as far as label goes. Once again, ideally you want that Googleable. That really is kind of the minimum. For tiny vials where that's not really an option just because it's so small, or it's a somewhat unknown or a complicated mixture, sometimes you do need to put some kind of sample number on it and then put some kind of reference sheet to what the sample number is. Make sure that reference sheet is readily available so that others can gain access to it and figure out what that chemical is. and if it's, you don't know what the chemical is, or you can't put what it is on there because you're going to use it as, an assessment of something, then give some context, Unknown B carbonate lab. Okay, I've got a pretty good idea what's in there. But I want the name of the chemical. If there's any particular known hazards, then you really should be labeling the chemical with those known hazards, especially if they're extreme. If they're extreme, it really needs those. Those are not optional if they are particularly hazardous. You need the date of the chemical. Some chemicals go bad. You want some context. So when was that chemical put in that vial? How old is this thing? And as well as, who is responsible for that chemical. So whoever put it in the vial, and then whatever lab they are working for. So you're going to kind of want a bit of information so that the next person can come by, pick up the chemical, and get an idea of what's in that chemical. Okay, back to me in the past talking about containers. If you are reusing one container into another, as long as they're chemical containers, that's usually not a big deal. Just make sure the old label is completely destroyed. Also, make sure you know what you're putting in it, what was in there, what's going in there. Make sure if a little bit of the old stuff gets in the new, that's not going to be that big of a deal. Ideally, you want to be either using a fresh one or using a chemical that's basically the same as the old one that was in there. So if you've got a hydrochloric acid solution, you dump out the old hydrochloric acid solution, you put in a new one of a slightly different concentration. Yeah, no big deal. Just, clean the container between the two. What you absolutely never want to do, though, is to use a food container for chemical storage. Now, obviously, you wouldn't want to use a chemical container for food storage due to contamination, but you don't want to use a food container for chemical storage because there is another set of labels that's kind of secretly hidden there. Back in the 19th century and early 20th century, a major health hazard was people at night going into their kitchen, grabbing what they thought was a bottle of beverage or food or whatever, taking a gulp of it, only to very quickly realize that that wasn't a beverage, that was a cleaning product. And that was a good way to get poisoned. So nowadays we have food container shapes and we have not food container shapes. And you don't put the thing in the wrong one. That way, if it's soda bottle shaped, it's food. It's not some weird chemical. Likewise, if it's chemical shaped, it's not going to be soda. At least not of the pop variety of soda. Okay, I'm going to wrap this up. I want to talk briefly about a couple of different organizations that are going to be involved in communicating safety and potentially enforcing safety requirements. The first is going to be the Occupational Safety and Hazard Administration, or OSHA. Now, this is coming from a US-centric perspective, but basically all developed countries are going to have their equivalent of OSHA. And this is a government organization that enforces safety policies for employers to ensure that the employer is treating their employees and making sure their employees have a safe working environment. So this basically means your company can't make you as your employee do something dreadfully unsafe, and in fact actually has to make you as the employee act in a safe way. You're like, but I don't want to wear my protective equipment. Tough, we don't care, you're gonna have to do this. Next group is going to be the Environmental Protection Agency. Now, people generally think they're there to protect fish and wildlife, etc., which is not wrong, but the other reason they're there is to help protect the community around the organization. So if you have a chemical plant and you're dumping toxic waste into the river, yeah, killing the fish is bad, but also like the people who are around the river are going to get exposed to your toxic waste. The EPA was created in the 1970s after a few events, including the Cuyahoga River fire, during which the river caught fire. I don't mean the boats on it, and I'm reluctant to say the water in the river because water doesn't burn, but the liquid in the river caught fire. People in the community and nationally was kind of dismayed that, rivers don't normally burn. And so there was motion to, not have this happen. My understanding is the Cuyahoga River, which is in Ohio, is actually doing quite well nowadays, and I believe you might even be able to eat the fish. I'm not sure on that one, so double check before you go out there with your fishing rod and a fry pan. The last organization I want to bring up is the Chemical Safety Board. This is a very small organization, and unlike the other two, has no regulatory power. What they do is investigate disasters of a chemical nature, such as a refinery catching fire, or a flour mill, the stuff that you make bread out of, going kaboom. Yes, turns out flour is explosive when kicked up. So if you don't clean your flour mill and you let large amounts of flour build up and then it shakes in the air, and yeah, you can have a flour mill explosion, which has definitely happened on at least a few occasions. They figure out what happens, look for the root cause, and then send advice to relevant other organizations, and have a wonderful YouTube channel, which I strongly recommend you checking out. If you like airplane crash investigations, you're going to love the CSB. The last one I want to mention is your organization's environmental health and safety department. Your organization, if you have anything to do with, say, health and safety, you're working with chemicals or whatnot, your organization will have at least one person whose responsibility is to ensure that the company or the organization you are with is following OSHA and EPA rules. And in general, make sure everyone is acting in a safe fashion. So you might not be yelled at by your government, but one guy that can yell at your boss may very well be yelling at your boss to yell at you for what you're doing. You get the idea. Now, this is actually one area where you can kind of evaluate your company. Some companies say, we're a big family and I would not want to be in such an abusive family as that company appears to be. Other companies, they actually do care about you and the leadership is actually supportive of their employees. One way you can tell is how well they treat safety. Is the environmental health and safety department actually trying to make a safe working environment, or are they just trying to do the minimum so they don't get in trouble with some various governmental agency? The other way is you look at the toilet paper. Good toilet paper is a good sign. Cheap toilet paper, it's also a sign. Okay, with that said, I will see you in later videos and have a wonderful day.